Factoring the difference of two squares. In order to understand better how to factor a difference of two squares, let's go back to multiplication. So let's multiply these two binomials, x minus 3 times x plus 3. When we go and multiply as we usually do, x times x is x squared, x times 3 is positive 3x, negative 3 times x is negative 3x, and negative 3 times 3 is negative 9. And when we go and combine the x's together, we see that x disappears. So the middle term disappears because the coefficients are opposite coefficients. And we are left only with the first and the last term. Okay, instead of having a trinomial, the middle term disappears and we have a binomial. And as we see, this binomial is a difference of the squares. Okay, so the product is a binomial and it is a difference of two squares. How we know that 9 is a square? We know because 9 is 3 times 3, and we say that 3 times 3 is a repeated multiplication twice. We write this in an exponential form, 3 to the second. So what this exponential form tells us? Same factors, two same factors. Okay, so 9 is a square number because it is 3 times 3, and we are very interested for this product, a number, an integer multiplying itself. Now let's go back and factor now x squared minus 9. Okay, we know now that x minus 3 times x plus 3 is x squared minus 9. If we go backwards, that means these are factors. This is a product. Now we have a product and we need factors. Those factors are two binomials. What we see in those two binomials, we see that the first term is xx. So both these terms are positive terms. So we write xx. And the second term are opposite numbers, negative 3 and positive 3. Okay? So in other words, we need two binomials, one to have a minus between, and another will have a plus. So everything else is exactly the same. X, 3, 3, one binomial contains minus, the other contains a plus. Okay? So let's generalize this. For any real numbers a and b, if we have a square, a difference of two squares, a squared minus b squared, we will factor into two binomials. One binomial contains minus, the other contains plus. And now, what are the factors of each term of our product or our difference of the two squares? Are the first terms in the binomials are the factors of a squared, and the second term of the binomials are the factors of b squared, and this minus and plus will produce us this minus here. So negative times positive is negative. Okay. Now, keeping this in mind, we now are going to work and to factor some difference of the squares. Okay. But for this, we need to recognize if we have a binomial that we want to factor, we want to recognize if this binomials is a difference of squares or not. And what to see here? If a binomial is a difference of the two squares, then the binomial must have two terms which are squares, and the first term is positive and the second term is negative. In other words, we have two squares as the terms of the binomials, and the signs of the terms are different. Okay, so let's recall some square numbers that we need in order when we see a binomial, recognizing that they are square, and they are, for example, number 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. I've listed some here that you need. Okay, and why they are squares? Because they are a product of the same factor. So 1 is the product of 1 times 1. 4 is the product of 2 times 2. 9 is the product of 3 times 3. 16 is the product of 4 times 4. So 25 is a product of two exactly the same factors, okay? And when we have this condition, we write this repeated multiplication in the exponential form. 1 times 1, it is 1 square. The job of the exponent is to tell us that the base is the same in multiplication twice, okay? So two same factors. 2 times 2 is 2 square, two same factors. 3 square, two same factors, okay? And so on. So let's go now and recall some square variables. So any variable that has an even exponent is a square variable. For example, x squared, x to the 4th, x to the 6th, x to the 8th, x to the 10th, and x in general form 2n. Why they are square variables? Because their exponent is an even number, and we know that an even number is divisible by 2. So if we want to write x squared as a product of two factors, we write x times x. If we want to write x to the 4th as a product of two factors, we write x squared times x squared. Okay? So we divide 4 by 2. 4 divided by 2 is 2, and this is the exponent of the factors. X to the 6, we divide 6 by 2. 6 divided by 2 is 3, and 3 is the exponent of the factors. See, x to the 3rd times x to the 3rd. If we want to write x to the 8th as a product of two factors, x to the 4th times x to the 4th. Why? Because 8 divided by 2 is 4, and the 4 is the exponent of the factors. And also x to the 10, if we want to write x to the 10 as a product of the same factors, so what is the exponent of the factors? It is 10 divided by 2, 5, and so on. Okay? And after that, if we have a repeated multiplication, we write it in an exponential form. So x times x is x squared, x to the 2nd times x to the 2nd is x squared raised to the 2nd power, and so on. So these variables are square variables. Now, and also in the general form, 2n represent an even number. So 2n divided by 2 is n. So n is the exponent of the factors. Okay? And written in an exponential form, we know 2 times n will give us back 2n. 2 times 5 will give us back 10. 2 times 4 will give us back 8, and so on. Now, let's mention here that variables that have an odd exponent, they are not square variables. For example, x to the 5th, x to the 7th, x to the 11th, x to the 13th. What is an odd number? An odd number is any number that is not divisible by 2. Why these variables are not square variables? Because, for example, if I want to write x to the 5th as a square variable, what can I write an exponent inside? I know that if I have an exponent inside, this will be multiplied with 2 and will give me an even number. Never will give me an odd number, 5. Okay, so these variables are not square variables, and if you see them in the binomial, you recognize the binomial is not a difference of the square, because on that binomial we need 2 squares. Okay, both terms are squares. Now let's rewrite again the general form. This is the form that we factor a difference of the squares as a product of two binomials. One contains minus, one contains a plus, and the factors of a square are a times a, two same factors, and the factors of b squared are b times b, two same factors. Okay, and this minus and plus give us this minus between a squared and b squared, because negative times positive is negative. So let's go now and do some examples. And the question is, factor each binomial completely. Let's do some examples. Example 1. Let's factor m squared minus n squared. This is very easy. This is almost the general form, just the letters are different. M and n are any real number. So I know how to factor. As a product of two binomials, one has a minus, the other has a plus. It doesn't matter when we write minus or plus. Now, what is m squared? What are the factors of m squared? Two same factors, 2m. m times m. So what are the factors of m squared? Clearly we see here two same factors, 2n's. N, done. M squared minus n squared is m minus 9 times m plus 9. Example 2. Z squared minus 49. So, is this a difference of the squares? Of course it is. Z squared is a square variable, 49 is a square number. So we have two factors, two the same factors, and here we have two factors, 7 times 7. Okay, we know this. So directly we go 1 plus 1 minus, same factors, same z, same factors, 7, 7. 49 is 7 times 7. That's it, done. Example 3. 4a squared minus 9 is equal to two binomials. One with minus, one with plus. Why I immediately wrote those two binomials? Because when I saw the binomial that I want to factor, I recognize square numbers and the square variable. Okay? So this is a difference of the squares. Now, let's simplify a little bit. So, in other words, when we want to factor a difference of the squares, we are looking for factors of the terms. Okay? For each terms, we are looking for factors, and factors are exactly the same. So 4, what are the factors of 4? 2 times 2. A squared, a times a. 9, 3 times 3. Done. Example 4. 25 minus 16b squared. I'm going immediately write the binomials. Why? One with plus, one with minus. I recognize that this is a difference of the two square. Square number, square number, square variable. Okay? So, what are the same factors of 25? 5 times 5. What are the factors of 16? 4 times 4. The same factors for b? B times b. That's it. Done. 5 times 5, 25. 4b times negative 4b, negative 16b squared. Okay? Example 5. 64 c to the fourth minus 9d squared. So, a minus between perfect square number, perfect square variable, so square number, square variable, square number, square variable. Yes, I can factor this. Is a difference of the two square. I'm checking, okay? Okay, now 1 with plus, 1 with minus, or 1 with minus, 1 with plus. So what is 64? 8 times 8. I'm looking for exactly the same factors for 64. 8 times 8. Now, c to the fourth. Fourth is an even number. 4 divided by 2 is 2. This is the exponent of my factors for c. C squared. Sorry, c squared here, c squared here. Let me erase this c here. Okay? Now, what are the factors of 9? The same factors of 9, 3 times 3. So what are the factors of d? D squared, d times d. Done. So I was rushing, I checked before I did this. Okay, now example 6. Let's see, 32 x squared y minus 18 y to the third. Okay, so let me check. Is this a difference of the squares? No, not yet. Maybe it will be later because I have a greatest common factor here. So 32 and 18 is divisible by 2. So 2 is a common factor for the coefficient. X is not present at both, so x is not a common factor. Y is present at both terms, so the smallest exponent, y, is a common factor. So 2y is the common factor, open parenthesis. So what is left now? 32 divided by 2, 16, perfect square number. X squared, perfect square variable. Y is outside, minus 18 divided by 2 is 9, perfect square number, or a square number is the same. From 3y, 1 is outside, 2 are left. So y squared is left. Square variable, yes. This is a difference of two squares, okay? This is very important. And now, do I know to factor this? Of course, yes. 2y. Never forget to write the greatest common factor. And now, two binomials. One with minus, one with plus. Now let's go a little bit slowly. 16 is 4 times 4. X squared is x times x. 9, 3 times 3. Y squared, y times y. Done. Example 7. 50 a to the third minus 8ab to the second. Now I have common factor here. So 50 and 8 are divisible by 2. A present here, a present here. So yes, a is a common factor, the smallest exponent. And b is not present at both, open parentheses. What is left now? 50 divided by 2, 25, square number. From 3a, 1 is outside, there are left 2a, that means a square variable, minus, which is important, minus, a divided by 2, 4, square number, a is outside, b square, square variable, yes. I can continue factoring, because, do you see the question? Factor each binomial completely, okay? So if you stop here, so you are not factoring this completely, so we need to continue. So I have 2a, the common factor, two binomials now, one with minus, one with plus, and now I am looking for exactly the same factors of each these things here. So 25 is 5 times 5, a squared is a times a, 4 is 2 times 2, and b squared is b times b. That's it. Done. Example 8. M to the fourth minus 81 n to the fourth. Is this a difference of the squares? Yes, it is. I know this is a square variable, okay? And 81 is a square number, and n to the fourth is a square variable because their exponent is even number, which is divisible by 2. So I am looking for the factors of m to the fourth, which are, so 4 divided by 2 is 2. So factors will have the power 2, the exponent 2. And n to the fourth also is n squared times n squared. Okay, I am ready now to factor. One with minus, one with plus. M to the fourth. Okay, even though you don't do this, you can go directly. What is the exponent of the factors? 4 divided by 2 is 2m squared. M squared. M squared times m squared is m to the 4th. 81 is 9 times 9. N to the 4th is n squared times n squared. 4 divided by 2 is 2. 2 will be the exponent of the factors. Done. Done? Not yet. So, only one check here. Why? Because after I factor, I have to check now both binomials. So this is a sum of the squares, but I have another difference of the squares now. Square variable, square number, square variable. So that means I have to continue and factor the first binomial. So I will have, for this, I will have 2 factors, and I have to rewrite the third one because I don't know how to factor a sum of the squares with real numbers. So I have to rewrite this m squared plus 9n squared. And now I will factor this one with minus, one with plus, and now I am looking for the factors of each term. So m squared is m times m. 9 is 3 times 3. N squared is n times n. Done. Now I have to two checks. So if you stop here, you factor this binomial, but not completely. Now it is factored completely. Now example 9. (16) y to the 4th minus x to the 4th. Okay, so let me go quickly now. The difference of the squares. How do I know? 16 square number. Y to the 4th is square variable because the exponent is even. X to the 4th even exponent, yes. I have a difference of the squares. One with minus and one with plus. And now, what are the factors of 16? 4 times 4. What are the factors of y to the 4th? I know that it will be yy. And the exponent of the factor is 4 divided by 2, 2. Y squared times y squared, check. 4y squared times 4y squared is 16y to the 4th. Now, what are the factors of x to the 4th? It will be x, but what is the exponent? 4 divided by 2 is 2. Okay? Or you can do it here. X to the 2nd times x to the 2nd, and you know 2 plus 2 is 4, and also here you can do, okay? But you don't need. Just divide the exponent by 2, and the result will be the exponent of the factors. Done? Done? Not yet. I have a sum of the squares here, which I don't know how to factor, but I have a difference of 2 squares. Square number, square variable, so that means I have to continue here. So let me go. Rewrite the first binomial. 4y to the 2nd plus x to the 2nd. And now, for the second binomial, I have factorization in 2 binomials, one with minus, one with plus, and now I'm looking for the factors of each term. Now, 4 is 2 times 2. Y squared is y times y. And x squared is x times x. That's it. Done. Now I have to check with 2 checks. Example 10. B to the 3rd minus 50 a squared b. Now, here I have common factors. Y? 2 and 50. All the time, when you see that you can factor something out, this is the first thing that we have to do. Okay? So, 2 and 50 both divisible by 2. So 2 is a common factor for the coefficient. B is present here. So the smallest exponent is the common factor. And A is present only the second term, so 2B is the common factor. Open parenthesis, what is left? 2 is outside. From 3B, 1 is outside, so it is left B squared. 2B minus 50 divided by 2, 25. So a square variable, a square number, A squared. And B is outside, close. And now I know this is a difference of the squares. Square, 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 a minus between. So I will continue. Let me rewrite the common factor. And now for the binomial, I will have a product of two other binomials, one with plus, one with minus. And now the factors of b squared are bb. The factors of 25 are 5 times 5. And a squared is a times a. Done. This was factored completely. First the greatest common factor, and then the binomial. Example 11. Y to the third minus 25. So, is this a difference of the square? No. Y to the third, 3 is an odd exponent, cannot be written as a square. So this is not a square. Even though 25 is a square, the first term is not a square, so I cannot factor, okay, with the tools that I have. You can continue when we learn how to factor. You will learn in another course, because, okay, I am skipping this, how to factor cubics, okay? This is a difference of the cubic, even though this is not a cubit, okay? So, unfactorable. Because it is not a difference of two squares. This is factorable, but with other methods, okay? Not with this. Now, example 12. X squared plus y squared. So I have squares, but I have a sum of the squares, not a difference of the square. So is not factorable with real numbers. Okay? So both of these you learn how to factor in other courses, okay? Not in our course. So example 13. Y to the 6 minus 49. Now, is this a difference of the two squares? Yes, it is. Why? Y to the 6 now is an even number, okay? In this case, y to the third, 3 cannot be divided by 2, but 6 yes. So this is a square variable. Now 49 is a square number, so I'm ready to go and to factor. One with minus, one with plus. Now, I know that the first factor will be y times y, but what is the exponent of y? 6 divided by 2 is 3. So 3 is the exponent of the factors. Check. Y to the third times y to the third, it is 3 plus 3, 6. Or, if you want, you can rewrite this again and write this as a square. And now 6 divided by 2, inside you will have a 3. So 2 same factors for y to the 6. And exactly what we did, okay? And now 49 is 7 times 7. Now, do I have another difference of the squares? No. Okay, so that's it, done. Example 14. 25 minus a squared b squared. So is a difference of the square, 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 between a minus, yes. one with plus, one with minus. The factors of 25 are 5 times 5. And now a squared is a times a, and b squared is b times b. Done. Example 15. So I have 12 x to the third y minus 75 x y to the third. Now I have common factors here. 12 and 75 both can be divisible by 3. So 3 is the common factor for coefficient. X here, so x, the smallest exponent, is the common factor. So x is the common factor. Y present at both, the smallest exponent is the common factor, so y is also a common factor. 3xy is the greatest common factor for this binomial, open parenthesis. And now what is left here? It is left 12 divided by 3, 4, square number. From 3 x's, 1 is outside, there are left 2 x's, square variable. Y is outside, minus 75 divided by 3 is 25, square number. X is outside, from 3y, 1 is outside, there are left 2, y squared, close. So we have a difference of the squares. We have to continue. So the greatest common factor, 3xy, and now I need two binomials. So what are the factors of 4? 4 is 2 times 2. X squared is x times x. So 1 with minus, 1 with plus. Factors of 25, 5 times 5. Y squared is y times y. Do I have another difference of the squares? No, I am done. Now example 16. 63 p to the fourth minus 7 p squared q to the third. Now, is this a difference of the squares? No. I think so, but let me see. So, do I have a common factor here? Yes, I have. So 63 and 7 are divisible by 7. Okay, so what else? We have p on the first, p on the second. P squared is the greatest common factor, the smallest exponent. And q is present only at the second. So 7p squared is the common factor, open parenthesis. What is left? 63 divided by 7, it is 9. And from 4p, 2 are outside, it is left 2p squared. Minus 7 is outside, p squared is outside, and I have q to the third. So this is not a difference of the squares. 9 is square, p to the second is square, but q to the third is not square. So I am done. So when I saw this binomial, when I saw q to the third, I didn't see q here. Immediately I thought that this is not a difference of two squares, but I had a common factor, so the only factorization here is the greatest common factor. So that's it. This was the lesson for today. I hope this will help you to do the homework. Thank you very much. See you on the next video, when I will talk about solving a quadratic equation by factoring. Thank you again.